Good day, students. Welcome to math.serve.com. In this clip, we're going to be going over problems 25 to 28 of the Algebra 1 Common Core Regents exam for June 2016. All right, let's take a look at question 25. It says, given that f of x equals 2x plus 1, find g of x if g of x is 2 times f of x quantity squared plus 1. Okay, so let's see what's going on here. We have f of x, and then we are asked to find out what g of x is. This is basically a composite function. So g of x is 2 times, yes, f of x, let's put that in green, f of x square minus 1. Okay, so what this new function does is it doubles the square of f of x and subtracts 1 from it. Okay, so how do we do this? In order to do this, what we're going to do is we're going to remove f of x from this function. So I'm going to have 2, and then I'll have parentheses, close that, square, minus 1. All right, what just happened here? Well, I take out this f of x. What I'm going to do is I'm going to take the value of f of x. Since f of x is 2x plus 1, wherever you have f of x in this function right here, this composite function, you can replace it with its value, which is 2x plus 1. All right, so I can take 2x plus 1 and insert it in the place of f of x. And there is your final result. Let's go ahead and box that. All right, let's take a look at question 26. This is determine if the product of 3 root 2 and 8 root 18 is rational or irrational. Okay, explain your answer. So you have to remember that irrational numbers can not be written as a quotient of 2 integers, whereas rational numbers can. All right, so let's consider some examples just to illustrate that point. So let's say I have the number 4. Is this rational or irrational? The question is, can 4 be written as a quotient of 2 integers? The answer is yes. You can write it as 4 over 1. Integer divided by integer, this is rational. Okay, how about 3 root 2? Can this be written as a quotient of 2 integers? The answer is no, because even though you put it over 1, these right 2 components is not an integer. So 3 root 2 is not an integer. So this expression right here, this term is irrational. Okay, so that's what I'm talking about. So let's go ahead and simplify the product of these two and see if we can express the final result as a quotient of 2 integers, which will make it rational, or if we can't, which will make it irrational. Okay, so we have 3 root 2 times 8 root 18. All right, so what we're going to do, we're going to multiply the integers, and then we're going to multiply the radicals. Okay, so multiply those two together. We're going to have 3 times 8. All right, and then the radicals, rad 2 and rad 18, we'll multiply them together. Root 2, root 18. Okay, 3 times 8 is 24, times the square root of 2 times 18 is 36. 24 times the square root of 36 is 6. 6 times 24, you can work that out in your calculator. 120 plus 24, which is 144. Okay, so is this rational or irrational? 144 is an integer. You can write it over 1. So this is basically an integer divided by an integer. This is a ratio of 2 integers. Okay, so we need to explain our answers. The result we got 144 over 1. The product is what? Is rational because it can be written as the quotient. Quotient is just a fancy word for saying the division or fraction, okay? It can be written as the quotient of two integers, 144 and 1. So that automatically makes our final result 144 a rational number. All right, let's take a look at question 27. It says, on the set of axes below, draw the graph of y, which equals x squared minus 4x minus 1. Okay, so when you're graphing a function like this is a quadratic function. The most important thing you want to ask yourself is, where is the vertex? Okay, because the vertex will basically tell you the axis of symmetry and shows you how you want to select or orient your points. Now you can do this with a calculator. It's pretty easy and straightforward, but let me show you how to find the coordinate of the vertex by hand, okay? So the vertex is simply negative b over 2a, comma, f of negative b over 2a. That's your vertex, all right? Okay, let's do that real quick, and then I'll show you how to do it with a calculator. X squared minus 4x minus 1. Now in this quadratic function right here, a is 1, b is negative 4, and c is negative 1. So the x-coordinates of our vertex, negative b over 2a, can be determined by plugging in b and a into this expression right here. So we have negative 4 over 2 times 1. All right. When you simplify that, you have negative 4 over, opposite of negative 4 over 2. Minus times minus, you slash and dash, that becomes positive. So you have positive 2 as the x-coordinate of your vertex. The y-coordinate of the vertex is negative b over 2, is f of negative b over 2a. So you just plug in the answer you got into the function. Okay, so you have parenthesis 2 squared minus 4 times 2 minus 1. So all you're doing is you're taking the 2 that you got here and you're plugging it in here and in there also. Okay. Okay, so let's work this out. 2 squared is 4. 4 minus 8 minus 1. So that's 5. So you have 4 minus 8 is negative 4. Negative 4 minus 1 is negative 5. Okay, so our vertex here is going to be negative 5. I mean, it's going to be 2 comma negative 5. Okay, so now how does this help us? Well, let's take a look at our graphing calculator real quick. I'm going to put in this function into our graphing calculator. And we have x squared minus 4x minus 1. Enter. Graph. Okay, so when I want to take a look at my table of values, where do I want to start from? Okay, when I'm sketching the graph, I want to start from the vertex right here. Negative 2, negative 5, that's where it is right there, okay? But I need numerical values that I can illustrate on my graph to help me graph my points. So I'm going to go to the table, okay? Now, guess where I'm going to look at on the table? I'm going to look for 2 on the x-coordinate because I'm going to have symmetry around that value. So you see 2 right there? It tells me where I want to start from. So I can have 2, negative 5, that's the center. And I can pick 2 values above and 2 values below, and that will give me my points, okay? So what I'm going to do is I'm going to copy this table over here. So it will be my guidelines for graphing the points of my quadratic function. Okay, so I did a screenshot right there. Okay, so let's copy now. I can just use 5 points. That should be sufficient for my graph. or maybe we can use more than that, probably use 7 points, doesn't really matter. Okay, so we're gonna go put -2 and then 2 up, 3 up and 3 down, okay? So that's 6 plus 1, that's 7. So 1, 2, 3, 4. So 1, 2, 3, 4, 5, 6, 7. All right. So just copy all those values. Remember, the action, what it's all about is mainly about this middle term right here, 2, -5. This is what's governing my construction. Okay, so I'm picking 3 values before and 3 values after. 1, 0, -1. And just copy from here, 4, -1, -4. And 2, 3, 4, 5. And then 3, -4, -1, and 4. All right, so all we just do is graph those points and we should be good to go. Okay, so this is my coordinate system. Of course, one is provided for you, or will be provided for you in your question booklet. So let's go ahead and graph the points. So 2, -5, 1, 2, 3, 4, -5, 2, 1, 2, 2, -5 is right here. That's the vertex, okay? That's the minimum in this case since we have an upward facing parabola. 3, -4. Well, let's graph the points to the right, okay? So we have 1, -4. So 1, -4 right here. Actually, yes. 1, -4 is this one right here. 3, -4 is this one right here. Okay. Now, one thing about graphing quadratic functions is since it's symmetric, you can always use symmetry to graph the other point. So if you have a point here, 1 unit to the right of this axis of symmetry, let me draw that in. So this is your axis of symmetry. So I'm going 1 point to the right. Guess what? I must have another point, 1 point to the left here. So you don't have to graph all the points. So this is 2, -5. And then this other point right here is 3, -4. Then when reflected across this axis of symmetry, you get the other point, which is, this point is 1, -4. All right, next point, 4, -1. So this is 1, 2, 3, 4. 4, -1, bam. 2 points to the right, guess what? 2 points to the left will take you to the other point. See how symmetry makes this nice and easy? So we have 4, -1 to the right of the axis of symmetry, and then 0, -1 to the left of the axis of symmetry. Next point, 5, 4, 5, 1, 2, 3, 4, like that. And then we're going 1, 2, 3 to the right. Guess what? Go 1, 2, 3 to the left to get the last pair of coordinates. So you have 5, 4, and then here you have -1, 4. All right, so just simply connect the dots to create your parabolic function. All right, so just do it to the best of your ability, and you should have something looking just like this, okay? All right, so there goes the graph of our function. And the last part of question number 27, we're asked to state the equation of the axis of symmetry. Okay, so this is the axis of symmetry right here, this line in the center. This is the axis of symmetry. So what is the equation of this line? That's a vertical line, which means that your x is always the same, okay? The y doesn't change, the y can vary up and down, but the x is fixed. So what is the equation of this line? You just pick the x coordinate, right? The x value right here where it intersects the x-axis. X is always equals to 2 on this vertical line right here. Whatever point you pick, guess what? X is going to be 2. So the way you write that equation is x equals 2. The equation of this line is independent of y. That is why we ignore it. So there goes the equation of your axis of symmetry. Okay, now let's take a look at question number 28. It says Amy solved the equation 2x squared plus 5x minus 42 equals 0 She stated that the solutions to the equation were 7 over 2 and negative 6. Do you agree with any solutions? Explain why or why not. Okay, let's go ahead and solve this equation. So we have 2x squared plus 5x minus 4. There are different ways to solve a quadratic. The method I'm going to use is factorization. Okay, I know for sure that I can factor this polynomial, this quadratic equation. How do I know that I can factor? Well, look at the potential roots she gave, 7 over 2 and negative 6. Hint, hint, there's a great possibility that I can factor it based on the nature of her solution. Had it been she had something like rad 7 and negative 6i and some radical component to it, then I will not want to attempt factorization. Okay, so I have a strong feeling that I can factor this because of what the answer looks like. So the what you want to take away from this problem is always use the nature of the roots to guide your problem solving process. Okay, all right, but there's no guarantee though. We're just making a informed decision. To factor this, we're going to use the AC method. So we're going to make ourselves a nice little diamond here. AC goes on top, B goes on the bottom. So AC is 2 times 42, 42, which is negative 42, which is negative 84, and B is 5. All right, so the question is, what two numbers multiply to give you negative 84 and add to give you 5? All right, this is not the easiest one to figure out. So what we're going to do is we're going to write down the pair of factors that multiply to yield 84 and see which combination gives us 5. Okay, so we have 84. What two numbers multiply to give you 84? 1 times 84 gives us 84. This doesn't work because when I combine it, either addition or subtraction, I get 85 or 83. So that's no good. 2 goes into 84, 42 times. If I combine these, I can get either 40 or 44. That's not 5, no good. Plus 3 go into 84, just add the 2 digits. 8 plus 3 is 12. 3 goes into 12, so 3 goes into 84. 3 goes into 84. 3 goes into 8 2 times. Carry 2, 24, 8 times, so 3 times 28. If you combine these two, you get either 31 or 25, which is not what we desire here. Plus 4 go into 84. Look at the last digit. 4 goes into the last digit, so 4 goes into 84 for sure. 21 times. If we combine this, we get either 25 or, let's see, if you subtract 21 from 20. If you subtract 4 from 21, you get 17, so that doesn't work either. Okay, 5. 5 doesn't go in here because the last digit is not 5 or 0. The 6 go. Absolutely. Since 2 goes and 3 goes, guess what? The product goes. So 6 goes 2. 6 goes in 8. 1, carry 2, 24. 14. Okay, yeah, so 6 and 14. If I combine these two, I get 20. If I subtract it, I get 8. Oh, that's close, but that's not what we want. Any other number that goes? Let's see, 7. Does 7 go into 84? Yes, it does. 7 goes into 84 12 times. All right. And then let's do a combination. 7 plus 12 is 19. 12 minus 7, 5. Oh, voila, that's exactly what we want. So 7 and 12. All right. Now let's resolve the signs. Since the sum is positive and the product is negative, that means that the smaller number has to be negative. Okay? So check. You always want to check your X game to make sure it works. Negative 7 times 12 is negative 84. Good. Negative 7 plus 12 is positive 5. Perfect. So when we can't jump to the factored state here. Okay, we can't jump into this final form. Why can't we do that? Well, because A is not equal to 1. Anytime you're factoring, you want to solve quadratics by factoring by grouping. If A is not equal to 1, you cannot jump to the final form. You have to factor by grouping, okay? So you're going to have 2x squared minus 7x plus 12x minus 42. Now what we're going to do is break it down the center and factor by grouping, all right? From the first two, what can we factor out from the first two? From the first two, I can take out the GCF, which is x in this case, so pull out an x, and you're left with 2x minus 7. Now, when you're factoring out, it's as though you're dividing, okay? So if I'm factoring out an x from these two terms, it's as though I'm dividing this by x and dividing that by x. 2x squared over x is 2x. 7x over x is 7. Okay, so please keep that in mind. Now let's shift our attention to the right side of the partition. What is the GCF of 12 and 42? We know that 12 goes, well, 12 doesn't go into 42. 6 goes into 42, right? 6 times 7. So the GCF, the biggest number that can go into these two, is basically 6. 12 divided by 6 is 2. 42 divided by 6 is 7. All right, so this is where you freeze and check. If you factor this correctly, guess what? The terms, the quantity in the parentheses must be identical. If they're different, then you made a mistake, either in your X game or your factorization. These two must be identical as a check to your factorization procedure. Since you're identical, we're doing it correctly. Okay, so we're going to factor the identical quantities out, and we're left with x plus 6. What do we do with those? We group them into their own parentheses. X plus 6 equals 0. This is a factored state. Now what we're going to do is we're now going to use the zero product property to finish this problem off. Okay, we're going to set both factors equal to 0 and isolate x in both cases. In the first case, you are going to add 7 and divide by 2. You have 2x equals 7, and then you divide by 2. And you have x equals 7 over 2. And in this case, you just simply subtract 6 from both sides, and you have x equals negative 6. All right, is that what Amy got? Amy got 7 over 2 and negative 6, so she is correct. Okay, so let's go ahead and explain our answer. That's what the problem asks us to do. So you can omit that written piece if you're asked to explain, because there are different ways you can solve this problem or verify that our answer is correct. This is not the only way. Okay, so conclusion. Well, I agree with Amy's answer. Because when you solve the quadratic equation by what? By factoring. That's the method we used here. So you can go ahead and specify the method in the problem. You know, it adds to the flavor of your explanation. By factoring, we end up with negative 6 and 7 over 2, the same answer as Amy. Okay, so just contextualize your result, explain what you did and how it aligns with Amy's response, and that's sufficient to get you full credit for the problem. Thanks so much for taking the time to watch this presentation. We really appreciate it. If you found the contents of this tutorial helpful in your review or preparation for the upcoming Regents exam, please give us a thumbs up. Your positive feedback is very valuable to us. Questions or comments should be included in the comment section below, and we'll be glad to respond. Don't forget to subscribe for updates to the remainder of this review series. More clips can be found on math.serve.com. Thanks again for watching.